Hi, everyone. Welcome to Product Days. I am Lynn from the product marketing team. Really happy to be here. And I'm here with Jed, our VP of Platform Strategy. Jed, do you want to say a few words about yourself by way of introduction?
Sure. Nice to see everyone. Nice to see you, Lynn. I am, as you said, the VP of Platform Strategy. That means that I manage the technical side of all our ecosystem integrations. So the big clouds, the big database providers, and now the LLMs, the LLM folks. In addition, I do a lot of work around envisioning what our roadmap should look like. And a big part of what that roadmap should look like is the architecture that clients have and the way that these architectures are changing over time. We need to make sure that we can change with them and help clients evolve. So it's a huge component of what I think about, and I hope that's what we're going to be mostly talking about today.
I think so. Can you start us off by just giving maybe a few examples of customers that you've worked with recently and maybe the types of challenges that you've helped them think about or solve?
Sure. So Dataiku has been around for a little over 10 years in the market. And in that time, I've seen so many different architectural structures. For a long time, Dataiku has been installed inside of the client's tenant. We were not a SaaS product for many years. And so installing inside the client's tenant means dealing with the decisions that clients have made architecturally, often dealing with years or decades of those decisions. So I've seen Dataiku installed as an edge node on a on-prem Hadoop cluster. I've seen Dataiku installed sitting alone in a GPU box, one of those on-prem NVIDIA boxes. I've seen Dataiku installed on all three major clouds using essentially every cloud database architecture that exists out there. And now I've seen Dataiku as a SaaS platform integrating through private VPN connections to the customer tenant. So really the whole gamut.
And so in that whole gamut, what do you see as some of the major challenges that you come across again and again that people are kind of facing?
I think that maybe the biggest challenge is that inside every organization, there is a team called enterprise architects. Not to say that this team is bad. These teams are good. They're very necessary. But they often have a vision of how everything should connect together and how everything should work. And getting Dataiku to align to that vision or convincing them that potentially a derivation or a deviation from that initial vision is going to be more beneficial to the users of an org is it's really a people problem, not a problem, a people interaction and a convincing people that Dataiku's relatively opinionated way of deploying and working within an infrastructure is the right way or a right way. That's the hardest thing.
Okay, so let's talk about that and Dataiku's kind of opinionated way of deploying. Let's talk about kind of three scenarios over the next however many minutes we have, 15 minutes. The first one being, what is our recommended way when somebody is coming from a place, a customer is coming from a place where they have sort of a very legacy infrastructure? And then let's talk about what is our recommended way for customers who come from a place of less legacy, maybe more modern data stack sort of picture. And then for the final part, let's talk about the future and kind of what things are looking like, maybe the trends that are upcoming and kind of what you're seeing, especially with Gen AI and LLMs in the picture. So let's start with the legacy. Can you walk through kind of what we recommend as the setup and then maybe some of the specific challenges that you come across with customers who have this type of setup and what kind of challenges they can maybe expect to face and maybe once they become customers, how they can mitigate those challenges or kind of what we recommend them to do to make that less friction?
Sure. So I wouldn't necessarily even say legacy. I would maybe say on-prem. So some of our very biggest customers, especially those with high security demands or high levels of regulation. So you can imagine financial institutions, government bodies, especially government bodies working in defense, have very strong requirements around, for example, nothing leaving their on-prem set of servers, actual hardware, which means none of the new fancy tools that many less secure organizations have the liberty of being able to leverage. Oftentimes, what that does end up meaning is still Hadoop. So people still have multi-petabyte Hadoop clusters out there that are running huge data engineering, data science, machine learning workflows every single day, every single hour, every single minute. The way Dataiku gets installed and interacts with those, I already mentioned it, but Dataiku gets installed on your customer hardware as an edge node of a Hadoop cluster. And the primary means of compute then is pushing Spark jobs or Hive jobs down to that cluster. In addition, usually the way clients are set up when they're working on-prem is that they also have a huge on-prem massive parallel processing SQL cluster. So a Teradata or a Greenplum, often both, which Dataiku is also going to connect to and push compute down to those places. So Dataiku becomes, when you're thinking on-prem, it's becoming a single pane of glass, a way for data analysts, data scientists, data engineers to come in and interact with what is underneath the covers an incredibly complicated technology. When people built these Hadoop clusters in the early 2000s, I guess not early 2000s, early 2010s, we'll say, what they were looking for was a single place, a data lake, where they could throw all their data into it. And then using these huge computational engines, you don't have to throw things into databases. You can start asking questions of this data directly. And that is true. That is what Hadoop does. Unfortunately, what the other thing Hadoop does is incredible. It becomes incredibly complicated and challenging to use if you're directly working with it. They spent millions of dollars putting their data into these large clusters and then realized that like 20 people inside their entire 50,000 person organization was able to directly work with this data because you had to, at the beginning, write Java MapReduce and then later Scala and then later PySpark. But still, a very small portion of people were able to interact with these things. And so having Dataiku as a visual pane of glass, as the best visual pane of glass on top of Hadoop in the world, was really how Dataiku got its start, and it's still how it's used at a lot of organizations.
What about organizations that are not entirely on-prem? So that section was really like 100% on-prem. What about organizations that have done some migration or they kind of have a combination of things? Is that kind of the same story or what's different about that?
Great question. So I can use an example of a major financial institution that uses Dataiku for thousands of users, is in the process right now of moving from entirely on-prem, and then as slowly their SecArch team approves more and more aspects of the cloud that they've chosen, they get access to more and more kind of cloud components and slowly move things from that on-prem environment into a cloud. Dataiku treats both on-prem and cloud resources in a pretty similar way. The cloud gives you more opportunities and offers more flexibility, especially around being able to spin up and down new types of compute. But underneath the covers for Dataiku, we just treat them all as connections, and we manage the credentials, and we push down compute everywhere we can. So you can have a Dataiku instance that is sitting on-prem and connected to cloud resources, as well as on-prem resources. That happens all the time. We have that major banking client currently has an on-prem instance still sitting on top of a huge Cloudera cluster that's also connected to a Snowflake database. And so they run some things on Cloudera that's still there, and they run some things on Snowflake in the cloud, but they have access to both through the same platform. And what's really nice is as they're evolving from that on-prem state to the cloud state, you have, let's say you've built a flow in Dataiku. I don't know how many people are out here listening to this know what a Dataiku flow looks like, but say you build a flow in Dataiku. A data set is a data set. Whether that's a data set for a Cloudera Hadoop cluster, or it's a data set for Snowflake, or it's a data set for Databricks, it's all just a data set. And so people who have built their full flow inside of Dataiku on Cloudera, and then that data gets migrated over to Snowflake, all you do is you swap out the underlying connections and your flow is still running. So that hybrid state is actually a place I think the Dataiku really excels, because we help you. You're not having to retrain everybody on how to deal with this new underlying infrastructure, which people shouldn't have to, analysts shouldn't have to care. They should just be able to work within the tool. And as that infrastructure changes over time, we can sit on top of it. You don't have to like do some massive single swap over, which is never realistic, right? If we waited for everything, if this bank waited for everything to be in the cloud to start using cloud resources, they would be waiting till 2029. Maybe they'd be waiting forever, right? That's just
Ever,
not
maybe.
a viable way to work.
Yeah. I talked to a customer just last week who said a similar thing. It stuck in my mind because he said they've been a data customer for a very long time, like 8, 9 years. And he said, our infrastructure and kind of setup architecture has changed like 3 to 4 times in that time. And our users have the same experience. They're interacting with Dataiku and it looks the same. So they don't have to worry about people having to change what they're doing or work in a different way.
Yeah, they went from MapR Hadoop to running in
You know
AWS.
exactly who I'm talking about.
I helped them do both of the transitions, so it helps. But yeah, they went from MapR Hadoop to uh, running Kubernetes, uh, Spark on top of S3 buckets, to running most of their workflows in Snowflake using Snowpark for the equivalent of being able to do Spark pushdown. And yeah, they did that over a period of years, all while people working on the platforms. They didn't have to have people stop working. They were able to do that pretty seamlessly.
Amazing. So we talked about full on-prem, we talked about hybrid. Let's talk now about full cloud, which is sort of like the a bit more we can call it modern, right? So maybe
Yeah,
someone who's coming from they're cloud native, they never had anything on-prem. What does that look like? What are the advantages of that? And yeah, how can talk about the frictionlessness of that?
sure. One of the biggest challenges of cloud is the plethora of choice. All three clouds, like we could just talk about, what can we talk about? Let's look at just at um, Azure. No, we can talk more generally. All three clouds essentially offer so many different ways of performing the same set of actions that clients are often overwhelmed by thinking they need to use all of them, or thinking they need to pick a single one. And it's sort of you get trapped in some type of stasis of choice, or stasis of the permanent architecture diagram phase of working, I guess, where you're iterating for years on, okay, we're going to have these 50 components all put together, and we're going to build all the glue in between them, and it's going to be perfect someday. And I think that's a real challenge that people, as they move to the cloud, have to overcome. Any of the clouds has many different ways of running. Let's say you want to run SQL on big data, right? Like in AWS, you could run EMR, you could run Redshift, you could run Athena on top of Glue, you could run your own Spark inside of a Kubernetes cluster, you could run Databricks on top of it, you could run Snowflake on top of it. There's the number of choices you have to write SQL and get information back from a data set is like so many. It's incredibly overwhelming. So oftentimes, yeah, there's this looping process of, oh my gosh, we need to figure all of this out before we can give it to people. What Dataiku does, as it did with Hadoop, is allow you to make smaller decisions without getting locked into a forever choice. So, all right, I have some data in S3. I can have Dataiku connect to it. Dataiku will manage spinning up an EKS cluster, and I can start working on that data right now. I don't have to build the glue. I don't have to stick everything together myself. I don't have to provide the platform. I can just say, all right, here's the data, go for it. And it doesn't mean that Dataiku is going to lock you into running Kubernetes on top of S3 forever. As we just talked about, that last client eventually made a choice to move their data into Snowflake, and the work they'd done in Dataiku let them do that pretty easily. As far as like what when I come in and I'm like, man, this is great. This client is going to excel, right? Uh, the way that looks is if I'm talking about it running in a client tenant, Dataiku has something called Cloud Stacks. So Cloud Stacks allows you very easily, without having to write any code, no SSHing into boxes, just point and click, allows you to spin up something called Fleet Manager inside of your cloud tenant. And then Fleet Manager itself can spin up many different instances of Dataiku. And these instances are perfectly set up. They're all the right security mechanisms are in place. All the right underlying runtime databases are correctly formatted. The sizing is good. Everything is ready to go. In addition, we spin up a attached or multiple attached Kubernetes clusters that are associated with that Dataiku instance. And then, in addition, it's great when a client is connected to either Snowflake or Databricks as a compute engine. By having both the Kubernetes cluster as well as a Snowflake or Databricks, you have the ability to push down compute to these large kind of SQL engines, these large infrastructure databases. Let those databases manage the metastore and all of that information about who has access to what, while we are able to push down compute to them. And then by having additionally, the Kubernetes cluster, it's very, very easy to, let's say, deploy web apps, deploy API services, deploy applications, deploy LLMs that all work with these Snowflake and Databricks data stores. So when I see a client with that setup, I'm like, that client is going to succeed.
This is going to be great. There was a customer last week who said their very favorite Dataiku feature was Fleet Manager.
Yeah, Fleet
So
Manager is awesome.
there you
I
go.
love it. It's made my life so much easier, or at least made the field engineers' lives a lot easier. Yeah.
There you go. So very different challenges in that bucket, but challenges nonetheless, just different ones. But Dataiku's there and can help alleviate some of those challenges in any case. It's great. Let's talk about kind of the third scenario that we have chosen, which is generative AI and LLMs. What does that bringing to the picture? What are the challenges that come with it? What are people struggling with in terms of the kind of a lot of what we talked about are like the choices they have to make.
Mhm.
Um, what's kind of the latest there, and what are you thinking about with customers?
Sure. So yeah, brave new world, LLMs. They have a lot of unique challenges, but they also have a lot of the same challenges that we've always seen. So I'm going to talk about the same challenges first, and then we'll switch over to unique ones. The same challenges that we've always seen are decisions like, is my data so secure that I need to stay on-prem or have my own LLM? Is it okay to send my data out to a third-party SaaS tool, which is essentially what all the API LLM services are? How do I store my documents or my data? How do I prep and clean my documents for storage so that I can ask questions of them? Um, what does my cost of all of this look like? How am I sure that I'm secure? How am I sure that my models aren't changing? We've been dealing with these questions with existing AI and ML workflows for 10 years, right? None of that is brand new to Dataiku, which makes us in a really great place to help clients solve them. Again, with choice, you mentioned choice, never has choice been more
Not a shortage
apparent.
of choice these days.
Not a shortage of choice, and never has been more apparent that choice is important. Um, you have different LLMs outdoing each other monthly right now. And you have different LLMs specializing in different capabilities. Like, oh, I'm really good at writing SQL. Oh, I'm really good at writing Python. I'm really good at understanding documents. I'm very conversational and funny. There are different LLMs. Oh, I can understand images and turn it into text, multimodal. There are different LLMs for different capabilities, for different costs, and these are changing constantly.
Can I
So,
try to do a little question there? Do you
yeah.
think that's going to get even more fragmented, or do you see that getting better over time as we progress through this?
I keep changing my mind about that. There's
That's
definitely,
the point. It's like nobody knows. We don't know what's
I
going to
don't
happen.
know. And I literally deal with this and talk about it every day. And I change my mind every time some new model comes out that is, very cohesive and incredible. I'm like, oh, this is the only thing. And then 20 new Hugging Face models drop that do stuff that that model didn't do. Yeah, so it's like kind of I don't know. Yeah, I really don't. And I think anybody saying they do, I don't believe that. I don't believe that they know, which means it's very important to have flexibility. Um, every client that we work with that is doing serious things with LMs, everyone is using more than one provider right now. They're using OpenAI and Anthropic. They're using um, Vertex and Azure OpenAI. They're using Bedrock and Hugging Face on-prem, right?
And is it for the reasons you mentioned about the capabilities of the LLMs, or is it a question of cost, or it's kind of a combination of both?
It's it's security, cost, and ability. So it's a combination of all three. And that kind of triangle is yeah, that's how you're making your decisions. And there is no single one right now, and maybe ever, that perfectly fits all of those for every use case. So yes, there's a LLMs, it's kind of all of the existing problems ratcheted up to 11, turn up to 11 from a Spinal Tap, anybody? Plus, there's a bunch of new problems. There's a non-deterministic nature of these things. You can ask the same question one day and the exact same question again the next day, heck, the next hour, and get a slightly different response. That's incredibly challenging to deal with and to roll out in a way that you're sure things are safe. There is the much higher cost per query versus the machine learning model. You deploy it on a node, the cost per query is essentially $0. Here, cost per query are varying based on the size of your input, the size of your output, what you're doing with the underlying document store. Yeah, extremely new challenges and potentially extremely high costs. Right now, everybody's undercutting each other on cost in order to get market share. But at some point, these things are going to have to make a profit, and you're going to see costs probably, I don't know about increase, but at least stabilize rather than being a race to the bottom. You don't have a strict evaluation technique. So let's say you have a machine learning model and you're doing a regression, right? You have a very clear R2 score, or you're doing a classification, you have a AUC, area under the curve. And you're like, okay, we know this is good. We've been using this forever. I can have a confusion matrix and look at that and be like, okay, yeah, I pretty much understand how my model is doing. With LLMs, there is no single metric, and there's not even like agreed upon set of metrics for tracking how good these things are doing. So the evaluation of the quality of these things is still not really established. Maybe the best way of doing it is asking your users to rate the responses and then putting that back into the algorithm to understand how things are evolving. But yeah, these are all very large problems. And Dataiku is dedicated to helping clients deal with these problems while feeling confident about being able to move forward. So once again, you don't get choice stasis, which is a real possibility here. You don't want to be drawing diagrams for the next 3 years while other people are deploying things.
Hopefully not.
No.
I feel like we can't have a discussion about future sort of architecture ecosystem without talking about GPUs. Like, is that something that our customers are talking about, and how are they kind of thinking about that as part of the LM discussion?
Sure. So the way Dataiku, I'll start with talking about the way Dataiku helps with LLMs. We have created something called the LLM mesh, which essentially allows you to plug different services or GPUs into a AI gateway or AI infrastructure that controls cost, auditability, has evaluation tools to understand how good your metrics are. It keeps track of toxicity detection, PII detection, allows you to create stop words, and basically creates a safe infrastructure around which you can build your LLM applications. And this infrastructure is agnostic and separated from the underlying LLM services themselves, which means that swapping out LLM services is as simple as like choosing a different one from the dropdown or choosing a single line of code. So having this infrastructure in place allows people to experiment with GPUs very easily. I talked earlier about having an attached Kubernetes cluster to Dataiku. You can leverage that Kubernetes cluster with GPUs on it and deploy Hugging Face models onto that cluster. Then you're running a local model on a large GPU. Of course, NVIDIA GPUs right now, but potentially more types of GPUs in the future as competitors catch up to run inference on your input text data. Again, this becomes as simple as a button click in Dataiku. Specifically around GPUs, like what kind of choices should you have to make? These things are greedy. These things are you need a big GPU for sure to run a good model, to run like Llama 3. Llama 3 70 billion is yeah, it's a lot. It's a big GPU. Oftentimes people will choose to run an on-prem model versus using an API service because they think it's going to be cheaper. And in certain perspectives, it can be. If you're running really, really huge text inputs to outputs, then yes, potentially it's cheaper. If you're running hundreds of thousands of, let's say you're running batch processes on hundreds of thousands of documents a day, and each document is 50 pages, that's going to be really, really, really expensive from a token perspective if you're running it in an API service. So I think there are really good reasons to run models on-prem in GPUs, but you really want to do that cost analysis and think long and hard about whether this can be an API service. For me, I always would choose to use an OpenAI API service unless I really had to run on-prem in a GPU for either cost perspective or for security needs. Something's like, oh, we absolutely cannot have this run outside of our environment. And yeah. But yeah, my choice. Or actually, the third reason I would run on a GPU, a model on a GPU, is if we had an example last year where the major models, the API service-based models didn't do multimodal yet, so they didn't do image to text. But we had a client who had a really good image to text use case, evaluating images and then providing descriptions of those images for product classification. We found a model called Lava, Large Language and Vision Assistant, that was in Hugging Face, and we deployed that model onto a GPU and were able to run that project and make it succeed in production back in November it was last November, back before the major API services had adapted. So I think if you want cutting edge stuff, if you have massive amounts of text data and you don't want to hit token limits, or if you are very high security, that's when you look for on-prem GPUs.
Amazing. You've given people a lot to think about. It's getting dark in this room where I am. I suppose I could turn on. I feel like I didn't want to do that in the middle. Oh,
Joys of being a global company. I have no idea what
from the beginning. So I think we'll wrap up. Thank you so much. Again, I think you've given people a lot to think about. We have plenty of sessions for the rest of product days about a lot of the topics that you talked about, especially in the last section. We have a session about LLM mesh that you should definitely check out either live or on replay, as well as several sessions about other generative AI capabilities that you should definitely take a look at. Thank you so much, Jed. And any final words for the crowd?
Keep innovating. Don't just build diagrams.
Love it. Thanks.
Bye.